So we are continuing on the subspaces. So this is the next example, that is find the subspace generated by polynomials. And what are they? They are, let's say, f1 x cube minus 2x square plus 4x plus 1, f2 2x cube minus 3x square plus 9x plus 1, and then f3 x cube plus 6x minus 5, f4 that is 2x cube minus 5x square plus 7x plus 5. Right? Are you with me on this? Yes?
Yes, sir.
So can you see something common between the nature of the polynomials?
So degree 3.
Yes, all have the degree 3, right? So we know that whenever we talk about the subspace of polynomials, we always say that degree less than equal. If we take the degree equal to or greater than equal to, then that set will not form a subspace. That is something which we have done in our past lectures. So now if you want to generate a subspace from these four polynomials, you know that this subspace can have the polynomial of degree less than equal to 3, because the four polynomials which are given to us are of degree 3. So the subspace generated by these polynomials can have degree at most 3. So if you take the complete polynomial, the complete vector space having degree less than equal to 3, then what do you think? What can be the dimension of that vector space?
So n+1.
तो इससे जनरेट होने वाले सबस्पेस की डिग्री ज्यादा से ज्यादा कितनी हो सकती है? यस
4.
यस, ज्यादा से ज्यादा 4 हो सकती है. But the next problem is we want to check that whether few bad elements are there over or not. That's what we want to check, right? So we want to check that whether some bad elements are present over there or not. Bad means if one is the linear combination of other, then this is sort of redundant information and we're gonna delete it using the echelon form. Okay, so what we're gonna do, we have done in this in the previous questions, we have taken this vectors in a row format, right? And we make the complete matrix in the echelon form. So here we will also apply the same thing. So we'll consider a matrix which will contain the coefficients of each of these four vectors, that is 1, -2, 4, and 1, right? So see this, the coefficient of x cube is 1, x square -2, x 4, and constant term 1. So I've taken these coefficients into this matrix. Now I'll do the same thing for the rest of the polynomials. So since here coefficient of x square is 0, so I'll take it as 0. Now we shall
Third row में -5.
sorry. So now we'll apply the row operations. Of course, we'll apply on R2 minus 2 times the R1, R3 minus R1, and R4 minus 2 times the R1, right? So just for the reference, I'll take this thing to the next page. So let's be over here. So this will become what? 1 minus 2, 4, and 1. So multiply this row by 2 and then subtract this row. Multiply this row by 2 and then operate R2 minus the 2 times the R1. So this will be 0. Multiply it by 2, that is 4. You subtract it plus 4, this will become 1. And similarly 8, this will become 1. Similarly, this will be 2, that will be -1. simply subtract 2, 2, and here -6. And next you have 0, -4, you add it over here, 1 minus 8 minus 1, 2, and you subtract it from here, so this will become 3. Yes, are you with me on this?
Yes, sir.
Okay, so next part is to make zeros over here. So I'll operate on R3 2 times the R2, and R4 simply add R4, simply add R2 into this. So this will be like 1 minus 2, 4, and 1. 0, 1, 1, and minus 1. So next one is 0, 2 times 0, 2 times 0. So here you put 2 times and then subtract it. This will become -8. Sorry, this will become minus will be plus -4. Then you add it. This will become 0, 0, 0 because 1 minus 1, 1 minus 1. So these entries will become 0 and you add it over here. This will become 2. Right? So now you know that these two are sort of similar and one can be discarded. So simply R2 operate on R4, R4 plus half times the R3. And this will be like 1 minus 2, 4, 1, 0, 1, 1, minus 1, 0, 0, 0, minus 4. And this will be 0, 0, 0, 0. And if you want to, you can do one more step by saying this R3 as -1 by 4 times the R3, just to, if you want to simplify again. So 1 minus 2, 4, 1. So 0, 1, 1, minus 1, and 0, 0, 0, 1, 0, 0, 0, 0. So that means dimension of such subspace. What would be the dimension of this W? Let's say if it is W, 3. And what will be the basis? The non-zero vectors which are present in this echelon form will form the basis for this subspace. So this will look like 1 minus 2, 4, 1. So these are the bases. So instead of writing in the vector form, we'll write it in the polynomial form. So that means x cube minus 2x square plus 4x plus 1. And next is x square plus x minus x. Next is simply 1. So this will form the basis for this vector space. Yes. Are you with me on this?
Yes, sir.
Okay. So now next part is
Excuse me, sir.
Anji.
सर सेकंड पॉलिनोमियल में -1 नहीं होना चाहिए
Yes, sir.
Second polynomial में कहाँ पे -1?
सर लास्ट में
Basis
Oh,
fact.
Square plus
yes,
x
yes,
minus 1.
yes, you're right. Yeah, I mean it is the constant term. It should be 1 over here. Okay, thanks for the correction. Okay, so next we have a V be a vector space of 2 cross 2 matrices. Of course, over reals, right? Over real. And W be the subspace generated by these matrices 1 minus 5 minus 4 2 1 1 minus 1 5. Next is 2 minus 4 minus 5 7, and the last one is yes, and the last one is 1 minus 7 minus 5 and 1. Again, we need to find the basis and dimension of W. Basis and dimension of W. That's what we want to find. So again, do the same stuff. So consider a matrix A, which will be, which includes these matrices. Now, how it will include these matrices? You simply open up and put it like vectors. That means 1, -5, then -4, then 2, right? So in this way, you write it as 1, -5, -4, and 2. Next one is 1, 1, -1, and 5. And next one is 2, -4, -5, 7. And the last one is 1, -7, -5, and 1. So you'll operate in the similar way. So you say this, operate on R2, R2 minus R1, operate on R3, R3 minus 2 times the R1, operate on R4, R4 minus the R1. So we'll get that 1, -5, -4, 2. And next, let me write it properly. Yes. So you subtracted 0, 6, 3, 3. Subtract it like 2 times and then subtract 0. So this will become 10 plus 10 and will become 6. This will become 8 plus 8 will become 3. This will become 4 and this will again become 3. So again you subtracted 0, 2, -2, right? And plus 4, that is -1. And then 2, that is -1. Yes. Are you with me on this?
Yes, sir.
So now you see that most of the rows look similar, and we know that out of these 3, 2 can be simply discarded, right? So you write it as, so let's, for the reference purpose, we'll take it there. So yes, you'll operate on R3, let's say on R2, R2 plus 3 times the R4, and R3 plus 3 times the R4. So what do you get? You'll get first row will remain same. Next will be 0. Next will be 0. And we are left with -2, -1, -1. This is in the lowest term. So you may simplify it in a way that you replace R4 and R3, sorry, R4 and R2, and further you can replace your R2 by minus times the R2, right? Just to simplify it. So 1, -5, -4, 2, 0, 2, 1, 1, and rest are the zeros, right? So now you want to write down the basis for this. So again write the matrix form, that is 1, -5, -4, and 2. Next one is 0, 2, 1, 1, but only for the non-zero entries, right? Zero entries will be discarded. So therefore, dimension of this vector space, vector subspace, is 2. Are you with me on this? Yes?
Yes, sir.
ठीक है, आसान है?
Yes,
So yeah, let's do the last part. I mean, last question for this. Sort of similar question which we have already done. Just for the practice purpose, I'm doing this. So let W1 and W2 be 2 subspaces generated by which vectors, and here I'm giving those vectors. So first subspace is generated by these two vectors, and second subspace is generated by these vectors. 2, 2 minus 1, comma 3, 0, minus 3, 2 minus 1, 2 respectively. Right? So again, find the basis and dimension of three parts. One is W1, another is W2, next is W1 plus W2. Right? And fourth part can be written as also find the dimension of W1 intersection W2. Now, this question is slightly different. Why? I'm going to tell you, right? So first of all, the A and the B parts are same. We don't have to worry about them. So let's see how it works. So for A part, you know that you take this vectors into the consideration, and now you shall apply thing R2 minus 2 times the R1. So let me take this to the next page. Right? So this is going to be 1, 0, minus 1. And this is going to be 0, and this will be 1, and this will be 6. Yes. Are you with me on this?
Yes, sir.
So now you see that both of the vectors are important for us. Why? Because we have reached to the echelon form, right? But nothing can be discarded. Nothing is 0 over there, right? So therefore, dimension of W1 is 2, and basis of W1 can be written as 1, 0, minus 1, 0, 1, 6. So this states that every vector was important for us. So now come to the second part. That means finding the basis and dimension of W2. So that is minus 1 to 2. 2, 2 minus 1. Next is 3, 0 minus 3. 2 minus 1, 2. Yes, are you with me on this? Now, here is a very basic question for you, and that is what? Can you be sure that few of the vectors can be discarded through the echelon process? Are you sure that you're definitely gonna get some 0 vectors in this particular setup? Yes.
Yes, sir.
Why is it so?
So they seem to be multiples of each other.
Even if they are not seeming to be the multiple of others, is it possible to say that the few of the vectors are redundant and we are not going to need them? We'll definitely kill them. तो पॉइंट ये है कि ये किसके सबसेट है, देखा जाए तो ये किसका सबसेट है, ये किसके वेक्टर्स हैं, R3 का.
Yes, sir.
R3 का है ना. तो R3 की डायमेंशन कितनी होती है?
3.
So 3.
Now how many vectors are there in this?
So 3. 4.
4.
Sir. 4.
4 vectors are there, right? So can the subspace, can the dimension of the subspace exceeds the dimension of the original vector space?
No, sir.
Not at all. R3 का सबसेट है तो R3 से ज्यादा की डायमेंशन वो दे ही नहीं सकता. So if a subset containing the vectors more than the dimension of its original vector space, then we are sure that few of them must be killed. In fact, at least one of them should be killed, right? ज्यादा से ज्यादा ये R3 बना सकता है, इससे ज्यादा नहीं बना सकता. So now let's see. So again we shall operate R2 minus R2 plus 2 times the R1, R3 plus 3 times the R1, R4 plus 2 times the R1. So this will become what? Let's see this. Minus 1, 2, 2. Multiply this row by 2 and add it into the row 2. So this will be 0. 4 plus 2, this will become 6. 4 minus 1, this will become 3. Similarly, 3, 0, 3, 6, right? So this will become 0, 6. 6 and minus 3, so this will become plus 3. Again, 0, 4 and 2, and this will become what? This will be 3, and this will be 6. Now you know that one of these two rows can be eliminated, right? So simply write the next operation, that is R3 minus the R2. See, so this will become what? Minus 1, 2, 2, 0, 6, 3, 0, 0, 0, and 0, 3, 6. Operate on R4. R4, 1 by 3 times the R4, right? And operate on R2, 1 by 3 times the R2. And thereafter, you replace R4 and R3. So this will become what? Minus 1, 2, 2, right? Or you replace, I would say, R4 and R2. So 0, 1, 2, 0, 2, 1, 0, 0, 0. Something like that. Now, this is still not echelon form. So you operate on R3 minus 2 times the R2. So this will become minus 1, 2, 2, 0, 1, 2, 0, 0. Now 2 times 4, 1 minus 4, that is minus 3. So 0, 0, 0. So now you are sure that it cannot contain more than 3 vectors. That is true. But even the lesser amount can be there, right? Subspace can have a dimension 2, can have a dimension 1, right? So that is. So therefore, basis of W2 is equal to, that is what? Minus 1, 2, 2, 0, 1, 2, and the next one is 0, 0, minus 3. So therefore, dimension of W2 is 3. Yes. Are you with me on this?
Yes, sir.
Guru?
Yes, sir.
And the third part, we know that how to, do the third part. That means for W1 plus W2, we take all the entries of W1 and of the W2, right? So starting from the entries of W1, so these are what? Minus 1. So let me copy this element and I'll put it over there. And we shall take the elements of W2 as well. Copy, and we shall paste them over there, right? So we need to consider this matrix such that this part is of W2 and this part is of W1, right? Now you're going to operate in a similar manner, but of course you have so many operations there. Of course, we'll take one by one, and that is operating on R2 minus 2 times the R1, Operating on R3, R3 plus R1. Operating on R4, R4 minus 2 times the R1. Operating on R5, R5 minus 3 times the R1. Operating on R6, R6 minus 2 times the R1. So now we shall have, I guess we should move to the next page. 1, 0, minus 1, 0. So here you multiply by 2, just a minute. Yeah. So you multiply by 2 and subtract, no matters, doesn't make any difference. So multiply by 2 and subtract, it will become 6. And here you add them, so it will become 0, 2, and 1. Here again, if you multiply by 2 and subtract 0, and here it will be 2, multiply by 2 and subtract, so it will become 1. Similarly by 3, 0. So here 0 by 3 and subtract, so it will add actually, so it will be 0, right? So next is, yes, are you with me on this? So next is 0, and here it will be minus 1 and 2 and subtract, add, so it will become 4. So operate on R6, R6 plus R2, and then operate on R4, R4 minus R3. So you are left with 1, 0, minus 1, 0, 1, 6, 0, 2, 1. So now you get 2 0 rows, right? And the last one is 0, 0, and 6 and 4, 10. Yes. Is it fine?
Yes, sir.
Okay. Now, what are you gonna do? You simply R2 or R3 minus, operate on R3 minus 2 times the R1. Sorry, 2 times the R2.
Yes.
Take. So 1, 0, minus 1, 0, 1, 6, 0, 0. So 2 times subtracted, this will become what? Minus 3. This will become minus 11. Yes?
Yes, sir.
So rest 2 are zeros and 1 is 10. So now this can be eliminated. कैसे? R3 में ऑपरेट करेंगे 1 by 11 times the R3. R6 को ऑपरेट करेंगे 1 by 10 times the R6. So this will be minus 1 and this will be 1. And after that, so I'm writing the combined operation actually. So after that, you're gonna say that you are operate on R6 plus R3, right? So now you are left with the matrix 1, 0, minus 1, 0, 1, 6, 0, 0, 1, and rest of the 3 are 0. So we know that at least 3 should be 0, right? क्यों? क्योंकि this is a subspace of R3, right? And we have 6 factors.
minus 1.
कैसे? हाँ, minus 1. ठीक है? So therefore, basis of W1 plus W2 is equal to 1, 0, minus 1, 0, 1, 6, 0, 0, minus 1. Right? Yes. And what is the dimension?
3.
Yes. And the last part, dimension of W1 intersection W2. So that will be, we know that dimension of W1 plus W2 is equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. So W1 plus W2 की dimension 3, W1 2, W2 3 minus W dimension of W1 intersection W2. So therefore, dimension of W1 intersection W2 is equal to 2. Yes. Is it fine?
Yes, sir.
See,
Yes, sir.
we have already done one such type of the question, but if you go back to that question, you'll come to know that there we also find the basis of basis of W1 intersection W2. But here we are not able to find the basis of the W1 and intersection W2. We are only able to find the dimension of W1 and dimension of W1 intersection W2. But there was also one problem. In those questions, we were not able to find the basis of W1 plus W2. But here we are able to find the basis of W1 plus W2. Because those questions involves few conditions. And if you take the common condition, you can easily reach to W1 intersection W2. But there was no way to reach at the basis of W1 plus W2, right? So see this, I'm just going back to that question. So yes, so here you can see that here we were finding W1, W2, and we were imposing only conditions, right? Yes.
Yes, sir.
So here we will have W1, and we have found the basis of W1 by substituting these constants, right? By using these conditions, we were eliminating one of them, and here we have eliminated the D, and that's how we have found the definition, dimension and basis for the W1. And W2 is also safe. But come back to the C part. C part doesn't, C part means we need to find out the basis and dimension of W1 intersection W2, not W1 plus W2. Why? Because these conditions cannot be added, right? We can only find the common conditions among them. So we take all the conditions. So that indicates the W1 intersection W2. So that's how we found the basis for the W1 intersection W2. And here we were only able to find the dimension of W1 plus W2, not the basis. But the question which we have done today, in this question, the things have flipped. We are able to find the basis of W1 plus W2, but we are not able to find the basis of W1 intersection W2. Yes, is this fine?
Yes,
sir.
So that's it for today.